Welcome to this webinar about GeoETL. My name is Hans Mellenberg. I'm pre-sales consultant based in the Netherlands, and I would like to have the next slide, please. So I will only do a very brief introduction of Talend, and this slide shows you a little bit about our history. As you can see, we are a relatively young company. We started off in 2006 as a French company building a data integration or open source data integration software. Since that at that moment there was nothing available in the market which was affordable and functionally rich. And progressing in time, naturally, data quality capabilities were added, and it's important to realize that that all the development has been done keeping the idea of a unified interface in mind. So whatever you want to use in Talend, you will always use the same development interface. So after data quality, master data management was added, and as a natural addition, application integration came on board. Application integration, which can be seen as an enterprise service bus. Moving on, big data capabilities were added. Okay, not moving on in slide. Can we have the previous slide, please? Sorry for that. So we've added big data capabilities, as you can see, and very noticeable in 2016, we have started to add self-service capabilities to the product line, both on standard environments and big data environments. And self-service, giving the business user the capabilities to actively being part of managing the data. And you should think about data preparation and stewardship applications, being very smartly able to help the business user form the data and make it part of a governed process. In 2017, you can see Talend really closely follows technical developments. All capabilities around cloud were really extended, and as you can see, we are really multi-cloud capable. So Talend will not only connect to virtually any cloud like Google, Amazon, Microsoft Azure, but it will also happily run in those clouds. It will also use the big data capabilities of those clouds, either from an on-premise installation or just completely native. And as you can see, the big data usage is moving on to real-time usage. So that this is also where the capabilities of Talend have been extended quite a lot. You can read the fast facts on the right. We are growing rapidly, very rapidly, with a 50% year-over-year growth currently. Can I have the next slide, please? Very briefly, you can look this up for yourself. You can see we are both Forrester and Gartner are noting us as a fast grower and high potential. So we are now in the right upper corner of both of those companies. And specifically with Gartner, you'll see that we are the only open source company in the right upper part of the quadrant, and also the only new participant in the 5 years. So really, I would say a rising star. Can I have next slide, please? So very briefly about Talend. So Talend has a unified interface. It's not going to charge by data volume, but just by data developer. So the price is becoming really predictable, and the modules you see on the screen are the specific functionality you're able to buy more or less separately. So that is the classical data integration and the less classical big data integration. It's the ESB, and on top of that you could add master data management, and of course cloud integration is a really important part of the offering as of now, and cloud integration capabilities just already comes with the data integration capabilities, but as an added bonus, Talend can also be offered within the cloud, so just as a service, where you would still, by the way, use the same unified interface of doing that, and again, we will happily run from any cloud or run within any cloud, and self-service, which is mentioned as data preparation, is now available very recently, all within the same unified interface, and can be easily used from the development interface. Next slide, please. So with this very brief introduction, I would like to hand over to Dr. Vasilis Kazakos from DISY for his presentation.
Thank you very much, Hans, and greetings from Germany. I hope you are all doing well. My name is Vasilis Kazakos. I'm head of business development and marketing at DISY. Along with me, I brought Akila Siriamulu. She's senior consultant and expert in spatial data management and data integration. And before I hand over to Akila, I just would like to make a brief introduction of our company. As most of you probably don't know us, we are a small and medium-sized company located in Karlsruhe. We have nowadays 70 employees, and we are in Germany a kind of leading provider of software solutions for data analytics, reporting, and GIS. Our business focus is data management and analytics, and as you saw also on the webinar, the topic of the webinar, we have a strong focus on geospatial data. So what we do are two things. The one is that we develop and implement large databases and data warehouse solutions with spatial and non-spatial data. For numerous enterprises, we currently have 300 plus large public and private organizations as our customers, mainly in Germany and Austria. Additionally, to provide a full solution, we have developed our own data analytics, reporting, and GIS platform. It's called CADenza, which is a platform for desktop, web, and mobile data visualization, data filtering, and data analytics. In order for you to better understand why we developed GeoSpatial Integration for Talend, let's have a brief look at what's our day-to-day business. Typically, customers have the challenge to solve problems related to data integration and visualization. And what we try to achieve is to help them to create data-driven or spatial data-driven answers and to make spatial data-driven decisions. We started with the environmental domain many years ago, where we now realize some of the biggest data infrastructures for public authorities in Germany and for nature conservation. And for instance, we collect their data from different sources, from sensors, from different applications, and create large data portals where the administration itself or the public can have access to this data, get information about, for instance, how clean is the water in a river section, which companies use the water upstream, etc. So there are typical spatial questions, and we provide the means for the governmental agencies as well as for the public to access this data. Another domain is infrastructure and noise, where we, for instance, built the largest data warehouse in Germany about for the railway authority in Germany. It was about noise protection. So what we had to do is to collect all the data in Germany, like railway tracks, buildings, elevation models, in a concise and consistent data model in order to calculate noise. So this is another typical example. In other domains, we are working in police and in security. For instance, you can answer questions like where were burglaries reported in the last 2 weeks, or how do I prepare my team for a major event. This is a typical questions which are around in the police or inner security areas, where again you have the spatial aspect. And another example is, for instance, in the agriculture domain, where we help authorities to evaluate and control EU funds to see if the reports by the farmers are consistent with the reality, or we help farmers to calculate crop yield in future in certain regions, or to see what damage might occur in case of a severe storm or flooding. These are all typical examples of projects we are doing. And if you start thinking about, you will find in most industries spatial related questions, like for instance, where are customers, where are my customers, where are my suppliers, what is the distance between our shops, how long does a customer need to go to a specific shops. You can find these questions in real estate. Where are my real estates located? Do I have to prepare for some regulations in specific areas for assets, etc., etc. So what we see the data integration process as we see strong spatial related aspects in the data integration process, and that's what we are doing. We do that in two ways. The one is we do data integration with Talend and GeoSpatial Integration. And the second thing is that we have developed our own visualization component. Actually, it's called CADenza. It's a GIS and reporting platform for desktop, web, and mobile. On the right side, you see a general architecture where you, in the green sector, you have the different databases we usually find at our customer sites. They have databases, several databases. They have sensors. They have several files. They have geospatial files or CSV files or access databases. And sometimes they have already GIS systems. They have services to be integrated. So what we do is we help them to create large data warehouses for data analytics and reporting and visualization of this data. And CADenza comes on top, where we configure CADenza to access all this data and provide the interfaces on desktop, web, mobile, and the resulting reports also as a service to third-party applications or to the end users. So through configuration, we can develop full open data portals, for instance. Additionally, we have a full security layer allowing powerful user and rights management, which goes down to full hierarchy of a public administration, which can be quite complex. And we have three ways to access this data via desktop, web, and mobile, and so that the data and the decision supports are available on all platforms. Before I finish, and just for you to get a glimpse on how this can look like at the end, here is some screenshots I prepared. Here you see, for instance, just a table view of the data. You can, on the left side, you can filter the data after you have prepared them with data integration. You can visualize them in a table, or you can aggregate them. You can group the data, further process them, export them, etc. for different applications, or you can visualize the data in a diagram way. You have all kinds of diagram types to visualize, and whenever you change the filter on the left side, the diagram changes accordingly, so it directly supports decision support. And of course, which is one of the key features of CADenza, is that we have a full-featured GIS, a Geographic Information System, integrated in the platform, where you can visualize all your data in a spatial manner. You can make spatial analytics on top of it. You can add spatial layers to the information, and you can create user-specific or application-specific views on the data. And finally, if you have to report, you can create also pixel exact reports, including diagrams or maps in the report, or tables in the report, which are automatically generated out of the prepared data. So that was all I wanted to make as an introduction to our company, Disy. Before I hand over to Aquila, who will guide you through a short presentation about GeoSpatial integration and about and will make the full presentation of the demo. We have prepared small polls just for us to better understand what our audience is. So I would like for you to hand over to Evelyn, and I would like to hand over to Evelyn.
Yes, like mentioned, we are going to do a demo. So just to get an understanding of where the audience is with Talend currently, do you already use Talend for your data integration projects? And I will just give a few more seconds because I see people are still voting on this. Okay, so if we look at that, so a lot of you already use the Open Studio or have a subscription, but there are also people there who have not used Talend before, so that's just good for us to understand when we get to the demo part. And then the next question, do you have geospatial data in your organization? I'm just waiting for people to vote on this. Okay. And it looks like mostly yes, so you're definitely in the right webinar as we are talking about this. So thanks everyone for voting, and I just have one more to go through. How do you currently transform geospatial data? And again, I'm just giving you a few seconds to vote on this. Okay, so a lot of you are saying that you don't at the moment, so that's again good for us to know. And with that, I'll hand it back to Akila.
Yeah, hello, here's Akila, and today we are going to focus on the data integration for Talend part and a special focus on the geospatial. Before we delve into the details, I would quickly like to say a few words about data integration. So as we all already know, data integration is nothing but one or more ETL process. What exactly is ETL process? ETL stands for, simply put, extract, transform, and load. Extract and load, just to say, is like you have your data from one or more sources, and you want to load it or store it into your data warehouse. For example, you have customer information in your database and you have the sales information maybe in a CSV file or an Excel file. And at the end, you just want to create a report which gives you the total sales information. And the transform part is where the magic happens, where your data actually transforms into a meaningful information. Maybe you want to add missing address information for your customers, or you want to calculate the average product sales per customer, and you want to store it as a report, or you just need it for your documentation purposes. What we don't see here is the geospatial aspect. And at DISY, or Disy as we like to call it, as data consultants, we deal with data integration processes day in and day out. And we need a platform where we can implement this ETL process. And we found that Talend, among the leading software platforms in this area with data integration at its core, provides us a maximum number of features to easily implement our ETL process. So today, you will be hearing a lot about data and spatial data. So I'll be talking about normal data and spatial data. So what I actually mean is normal data is alphanumeric. So all the text, all the numbers, dates, phone numbers, customer names, that's your alphanumeric data. And the spatial part, what is geospatial data? As soon as you want to represent something on the earth, some real world entities, and you would call your data geospatial data. And we usually consider that geospatial data has two parts. One is the geometry types. So you look out the window and you see the streets and your city, and you want to represent this in your database. So you might want to use these geometry types like points, lines, and polygons. So you have a street, and streets can be represented as lines. And you want to map or represent your street lamps, and that can be represented at points. What about the buildings, their surfaces or areas for which you could use the geometry type of polygon? But sometimes there are also scenarios where you want to group together a number of buildings as a building complex, or I don't know, a position of the Wi-Fi routers in your building as a bunch of points. So in that case, we would need something called multi-geometries, which is a collection of the same or different type of geometries. When you use the same type of geometry, it's the multi-geometry, and when you use different types of geometries together, it's called a geometry collection. And the DBMS, or the databases that you currently use, you would have heard that these are the most common geometry types supported by most of the DBMS currently in use. So this is the first part of geospatial data. So the second part is the coordinate reference system. This in turn composed of two different parts. The first one is the geodetic reference system, which is in turn the geodetic datum of the Earth. And you might have heard about WGS 84 or ETRS 89, and this is the physical, this comprises the physical component of the coordinate reference system. The second part is your coordinate system. This is how you actually represent your geometry in the databases. Maybe you have heard about latitudes and longitudes, or in a certain area, we measure points in terms of degrees, or in other areas in terms of meters. And the combination of the geodetic reference system and coordinate system is what makes up a coordinate reference system. There are combinations of these two systems have a standard code, which is called the EPSG code, or you might be familiar with the SRID. It stands for Spatial Reference Identification Number. So here I have a few examples of EPSG code. These are the common codes that are used for Germany. We have the Gauss-Kruger projection system for Zone 3, and we have the WGS 84 for 4326, which is commonly used where coordinates are represented in lat long. So that is geospatial data for you. So coming back to our classical view of ETL process, now that the geo data is in play, how does this process change for us? So basically, the process is the same. So we want to read, other than the normal data, we also want to read the spatial data, and we want to load or save it into our different data sources or data warehouses. But the thing to consider here is now the spatial data are not just text and numbers anymore, and they have specific formats. And each format is supported in a different way in each database management system, and they have their own interfaces. For example, in Oracle, you need a spatial extension part in order to support geometries. And in Postgres, you might have heard about Postgres extension in order to support geometries. So the platform that we use, which is Talend, needs some more features or components which enables us to do the magical part, which is transformations. Transformations, you could think for geospatial data as geometric operations. Maybe you want to transform coordinate from one system to another, or you want to find out where your all the supermarkets in your region, or all your coffee shops in your region, or maybe you want to calculate the distance of a street or an area of a polygon. These would include geometric operations. Sometimes you don't want to generate geometries. Transformation doesn't exactly mean that you're handling geometry data, but all you want to do is answer yes or no questions. So does the supermarket really have this PIN code? Does it really lie in my region? Does this address information given by the customer have the correct PIN code or zip code? I want to correct it. And here you would have to use your spatial knowledge. For example, you would use intersect in this case and correct your existing normal data, which is non-spatial data. And you have to combine both. We have to use the knowledge of both geospatial and the normal in order to make our data useful information. And this is what we missed when using Talend as a platform, this GeoSpatial Integration. The GSI stands for GeoSpatial Integration. So as Disy, I have already mentioned, we are data consultants, and we have a lot of projects where data integration is a vital part. And we've looked into so many tools that are currently available in the market, and we try to evaluate them based on certain criteria. The first is that, of course, the technical requirements of the software, or the functional requirements, so to say. Does the software support all operating system or most of the operating systems? So does it support all the data formats that are currently in use in our organization? How many features does this software provide? Is it easy to get from the development stage of our processes and getting it into a production stage? That is what we mean by deployment. And is the software cost effective? Cost effective doesn't only mean the license cost of the software itself, but also if the software is time and labor intensive. So these are the functional requirements. Of course, when you talk about software, the non-functional requirements are also important. How good or how easy it is to use our software in order to implement the process that I have as an idea. How good is the documentation? Is the software comprehensible? So we do have a lot of projects, and we deal with a lot of really huge organizations which have an ever-growing complex infrastructures, and the processes also gets more and more complex. And many people would be working on the same process or a project. So this is where the following factors are also important to be considered when you talk about a data integration platform. Version management, for example. Can many people work on the same project and without having any synchronization problems? Is my process manually or automatically schedulable, so I don't have to really monitor everything? Do I have options to monitor the performance or optimize it? How good is maintaining of the processor or the complex processes that I create? And of course, the most important is the information that you receive from the software itself, the logging on error. So based on all these factors, we've come to a conclusion that Talend for us satisfies most of the criteria, if not all of our criteria. And that is why it's one of our favorite tools to implement data integration in our organization. So for those of you who have no idea about Talend, maybe I'll just say a few words about what's Talend all about. So here I have a small screenshot of an ETL process. In Talend, we call this a job. You can have one or more jobs for your entire ETL process. And Talend is basically a graphical tool. All you have to do is drag and drop a few components. These tiny icons that you see are called components. And your data flow is connected through rows, or the lines that you see here. Talend has such components, so many that you can just drag and drop, and you can connect, and you have complete control over your flow of data. Talend also has options or possibilities where you can reuse the existing information again and again, which is also called the metadata, which is what we mean by management of integrated data source and the target. At the end of the day, Talend is basically a Java code generator. Whatever you build on the graphical part of this ETL process, Java generates in the background the Java code, which can be run on many platforms. And this helps us integrate the data, create jobs without any knowledge of programming, and reach our destination or generated data that we need. So we've talked about the data integration process and the geospatial aspect, and we have this great tool, Talend. So far, what we were able to do, this is a scenario so far, when we talk about geospatial integration, we modify the ETL process as just ENL. All we can do so far was just read the data from one source to another without any form of transformation and directly store it in your database, and which from the poll, I understand most of us already do. Or we modify this process as not ETL, but ELT. So we extract, load it into a database, and again, from the poll, I could see that they use other tools like the functionality of the database itself to deal or extract information from the geodata. So, which means this is also the case with us and with most of our customers. They use different databases, and their knowledge, it's a prerequisite to know good GeoSQL in order to generate any meaningful information. So that is why we partnered with Talend, with a great tool and all our requirements and ideas. And without further ado, I would like to roll out the red carpet and to introduce our brand new GeoSpatial Integration. So what is Disy's GeoSpatial Integration? It is basically a plugin. This plugin takes advantage of all the Talend's existing features and infrastructure and adds the spatial functionalities to this. It is as easy as installing, just copying a few file folders in your local system and restarting your software. And it integrates seamlessly with the Talend existing interface. You won't know the difference between normal components and our Disy's geospatial component. And this plugin is also supported in the normal Talend Open Studio and also the enterprise version or the subscription Talend version. We currently support through this plugin the spatial data formats provided by Oracle, PostGIS, Spatialite, Shapefile, and WKT, which stands for well-known text. And we are only at the beginning. That means we have implemented all the functionalities that we find are required in our day-to-day life in our customer projects, and you can always expect more features to come. This is a screenshot of Talend Open Studio desktop interface, and you can see our plugin camouflaging itself along with the other components or plugin tools. And like we said, it has really good integration with the Talend Studio. You can use it in combination with all the other Talend components. And we focused on the easy use. And we've also taken our 20 years of expertise in data warehousing to implement all the functionalities that we find we needed without fail in our processes. Yeah, a little bit detail to the functionalities that we offer through this plugin. We have categorized it, as you can see, as calculators, data quality, databases. These are self-explanatory. So all functions related to database are grouped under databases, and all calculations that can be done under calculator. For example, you can calculate area or coordinates. Filtering, it's just answering your yes or no questions, to name a few functions. Apart from these components, which you can drag and drop, we also have special functions which you can use in Talend, which we'll be seeing in a short. So I'll go into the live demo where I'll show you how Talend works with GeoSpatial integration. And today, in order to demonstrate this, we have chosen a scenario. So these are two common duck species that are spotted around the area of Saxony. And the data comes from two different data sources. And when we visualize this on a map, it looks something like this. These are where the points have been spotted. I'm sorry, spotted in the region of Saxony, and in the background you see a grid of 10 kilometer by 10 kilometer cells. And what we aim to achieve from this data is to classify the cells based on the number of observations found on each cell. So we want to achieve something like this. This is a real-time project that we currently have with our customer in Saxony. So I'll shift to Talend. Yeah, so this is Talend Open Studio. For those of you who have never used Talend before and not familiar with this, I'll quickly give an overview of the interface. On the left side, you see the repository view. This is the entire structure of your project. The job designs, for example, is where you define your ETL processes, and you can group one or more processes based on, or processes or jobs, based on the functionality. You can see there's demo and preparation. And what's important here is also this metadata. I just mentioned that Talend provides us a way to reuse our existing or known information. And this can be defined like, I want to use database connections, and I can define this connection which I can reuse in my jobs. Right. This is the workspace area. You can see my pointer, I hope. This is a workspace area where you define your jobs. For example, here I have a ATL process which reads the airports from a spatial light database and splits the data flow into two, and it calculates the buffer area around the airports, and then I'll receive a shape output. You can see the components that I've used here on the outline are plugin components. You can find under the palette. If you want to use any of this component, you can just drag and drop the component. I'll just drag and drop a component just to show you how. The difference here is that you can see all the Talend components starts with the letter T, which stands for Talend, and the Disy or GeoSpatial components, plugin component, starts with the letter D. And each component have their own properties. I'll double click on one of the components. So here you can define the EPSG code. In Spatial Light, you can define the connection parameters or your query or your structures. It is very similar to all the Talend components. Okay, so getting back to our scenario. So I told you I have the observation information of the ducks, the common species of ducks, which for me, it's an Excel file. And here I have the ID of each of the observation, the type of the species, and the name of the species. Here we have mallard and pochard, and the year of observation, and the coordinates in form of numbers in 2 columns. So we would like to use this data, and my grid information, I'm switching to the SQL developer in Oracle, and my grid information is stored in a table. Here it's called GeoLAEA, stands for Lambert Azimuthal Projection, and it has the cells, and the cells are 10 kilometer by 10 kilometers. So here we just have an identification for each of the cell code, and you can see how the geometry is represented in an Oracle database. So we have 2 data sources, and we need to use these 2 data sources in our Talend environment. Okay, so I'm going to create a new job. So this is, I have a new folder, webinar, and I just right-click on it to create a new job. Today we want to find out the distribution of the species of ducks. So I'm going to name my job as species distribution. Of course, the purpose is Talend webinar, and I'm just clicking on finish. So I have this new job, and I want to tell Talend to use the 2 data sources. So I've already added a data source for the Excel file, which is called observations. Maybe I'll delete this to show you how I can create it again. So, okay, I just wanted to demonstrate again how I've defined a data source. So I'm creating a new Excel file, and this is called the observations. This is the Excel file you just saw. I'm clicking on next. And I have to choose where my Excel file is currently in my file system. It's in my local system. I'm just using the observations file, and it automatically identifies the existing data from the file. So I have only one sheet in my Excel file, so I'm just selecting that and clicking on next. So Talend automatically tries to read the data that's existing in this Excel file. And here you can see that it identifies the first row as data, but first row corresponds to the attribute names or column names. So I'm selecting this option, set heading row as column names. And refresh preview to see if the data has been read properly. Yeah, so this seems to be in order. So I'll click on next. Right. Here, the Talend automatically identifies the data types that are present in our Excel file. And this data structure, I'm going to name again as observations. And here's where I can correct if there's any difference in the type. For me, it seems to be in order, but I want to define, for example, the observation ID as the primary key, which uniquely identifies observation or a data row. So I'm selecting on that, and all other data types for me seems to be in order. So I'll just set the default, and I do not want any of the data to be null. So this field is for nullable, and I'm deselecting it. So it means that data has to be present. All these fields have to be filled in order for the data row to be correct. So I'm clicking on finish, and that's how you tell Talend that there's a data source that has observation. So to use it, I just have to drag and drop. Talend automatically identifies the data type and provides me all the components that can be used for this. Right now, we are reading the data from the Excel. So I'm just selecting the file input component. Okay, so that's our Excel file. So we still have to add the data table from the database. So I've already added the connection to my database that I showed you, the GeoLAEA table. I'll click on it, double click on it again to show you the structure. So we've already seen this table as a code or identification for each cell and a geometry. And you can see Talend has identified the type of geometry as the STO geometry. This is the name, the column is the name used in Talend. It's the database column and the database type. And you can see this is the Talend type, which is currently identified as object. Okay, so now I'll add this source also in my job. And again, Talend suggests me all the available components, and you can see there's also a plugin component that is available. Right now, we are just reading the data from the table, so I'll select Oracle input. And I've stored my information in a context, all my access information to the database, so I'll just click on yes to take that. So now we have two data sources. We know this observations have no geometries, and I have to define one. For this, I will be using from the palette, from our plugin in our GeoSpatial, in geometry operation, I have a component called D point from coordinates. So I can just drag and drop this component onto the job. So I want to transfer my data from the file to the component. So I'll click on row, main. This is how you transfer your data, right? So I'll click on this component. Here we have to see if the data has been really transferred. So I'll click on the edit schema. Okay, now you can see the input data has been transferred to the component. Here we want to generate the data from the X and Y, and we want to store it in a new field. So I'll add a new field and call it geometry. And geometry is naturally not a string type. And because we use the GeoSpatial plugin, now we have the option that's called dGeometry, stands for Disy geometry, and this has to be defined. Okay, so, and I also have to, I'll close this palette so you can see better. Right, so this component now has two options. So my input X field is the X column from my Excel file, and the Y value is from the Y column. That's fine. And I mentioned the unique coordinate reference system, and this data is in Germany, and it's got this system which is a universe transverse Mercator projection for the zone 33 in Germany. And I know this data lies in that code. So I'll select that one too. And of course, I have to choose the output geometry column. So now we've told Talend that there's a new geometry type. And we have to do that similarly for Oracle. We are reading the data from Oracle, and we want to convert it into a Talend type. For this, I'll use the component from the GeoSpatial, the Oracle. Of course, you can either drag and drop this component from the palette, or you can just type the name. And as you can see, this converts the Oracle object type to Talend geometry. So I'll double click on it and add this to my job. So again, I'm connecting the data flow from the database to my component. And I have to make sure that all the information has been taken here. You can see there's on the input, I want all the information as an output. So I'll click here, OK. So the information has been transferred. And it is important here to see that the type is no more object, but Talend's geometry. Okay, so now we've defined there's two different types of data, and now we need to connect these two data. We want to find how many points lie in a certain grid cell. So for that, Talend has this component called TeamApp. It is used to join the information from many components and process it. So I can do this. I can just create a new row and connect it to the map. And this is basically our observation points. So I can also rename it as observations. So it's more meaningful to me. And I'm going to look up my grid values from here. So I'll connect also this information to my TeamApp. So basically, this is the grid. So I'll just name it as grid. So we have two sources of information in this component. So I'll click on Talend TeamApp component. I'm double clicking on it, and you receive this view. You can see both the informations are there. And now I only need the points that lie in a certain code. For this, I will have to filter my data. So I enable this expression filter here for the grid. And for this, we would use the function called intersection. So I'm clicking on this expression field here. These are some of the common expressions or filters that are functionalities that are available in Talend. And here you can see, because of the plugin, we have 4 more geometry or spatial functions. So we're filtering the points that are in the grid. So for this, we need the intersects option. As you can see, it tests whether two geometries intersect. So I'm double clicking on it so I can use this function. Okay, so now we need the two geometries. So I need the point geometry from the observations, and I want the grid geometry to see if it lies in the grid. So that seems good, and I'll close the bracket. Okay, so you can see these two fields have been connected to form a filter. So this is my input, and now I need an output. My output, I'll just name it as output 1. This is not our final result, so it's an intermediate result, so I'm naming it as output 1. And here I would like to have the name of the species, the duck species. I would also like to have the observation ID. Okay, I can also move it up. Okay, and I would like to know the year in which the observation was made. And what I would also like is the cell code of the grid in which the observation was made. And here you can also define which is the key identification that defines this output. Cell code is not our key, so I'm disabling the key. Okay, our intermediate results seems good. So I'll apply it, and now you have an intermediate result. So this would just filter all the points that lies in the grid of Germany. Now I want to calculate the number of points that's in each cell. For this, we have to group the points together based on certain criteria. Again, I use a Talend component called T-aggregate row. So each observation has to be grouped based on 3 columns. So I'll transfer my output, which I generated, to this aggregation. And I'll check if my output has been transferred, which is not. So I'll click on this double file to take all the fields. Okay. Now I'm in the component view of the T-aggregate row component. So here you have the option to group the results. So I want to group based on the species name, that's type name in our case, based on the year on which it was observed, and also based on the cell code. So I'll define it here. Right. So now we want to calculate the count of the rows. So we need an output column. We have not defined in which field the output has to be saved. So I'll go on the edit schema again. So we only have 4 input and 4 output, but we want to save our new result in a new column, and I'm going to call it the count. And count is, of course, a number, so I would also set my data type as an integer. So my output, I need it in the field the count, and it will count, the function is count, we'll leave it at that, and this will count the number of observations, grouping it by the species, year, and the cell code. So now I have the count, we're almost there, bear with me. We want to write the results in a database. My database table is called GeoSpatial Distribution, which I've already defined here. If you want to look at it, I'll quickly shift to Oracle SQL Developer to show what the table looks like. This is the table. You just have an ID, the species type, the year, the cell code, and the count. So this connection I've already defined in Talend. So I want to tell Talend to use this component, so this connection. So this is an Oracle component, and again, I have options to use various Talend components. So I'm not reading the data, but I'm writing to a data, so I'm selecting the Oracle output component. Okay, we're almost there, but there is something I have to do before the data is written to the database. You will see it in a minute. I'll add another TeamApp component, and I'll transfer my results to the TeamApp component, and then this result to the Oracle component. And this is my end result, my final result that I want, so I'm going to name it as result. And it's asking me if I want to read the schema of the target, which is our Oracle database, and I need that, so I'm clicking on yes. So the effect, you would see I'm clicking on the TeamApp component 2 here. I'll double click on it so you can see. So this is my input, and this is my output. The reason I needed the TeamApp component here is that you can see not all field names are the same. Some of them are the same, but type name, for instance, is stored in my database as species. So I'll auto map, so all the same ones are automatically mapped, so I don't have to drag and drop, and I can manually say the type name corresponds to the species name in my database. And I also need a special identification number, which will define my results unique, identify my results as unique. So this is not the same as observation. This is the result of the group, so I'll just generate a sequence automatically, and I'm pressing Control-Shift for automatic options. So here I have the Talend functionality called sequence, so I'm just selecting that. So it automatically creates a number sequence which starts with 1 and increments with 1. So now my data is final, and it seems good. Okay, if I've done everything right, my job should work fine now. So I'm shifting to the run view at the bottom. So this is how I start the entire process. So fingers crossed. So you can see the Talend retrieves all the lookup grid values, reads the data from our Excel file, generates geometries, and consolidates this data and writes this into a database. Oops, I seem to have forgotten something. So here we have defined there's a unique identification, and that might be existing data in the table. So I can say truncate, delete all the old information. And I'll also look at the component here. Everything seems fine, and none of them should be empty, I think. This can be empty. Okay. I'll try the job again. Yeah, so it's quickly okay. Apparently it has not grouped all the results. Oh, yeah. Apparently I've mapped the wrong field here, which it has to be grouped based on the cell code. Right, so one last try. It reads all the data. Now you can see that the data from the Excel file and the database have been grouped together. We processed and we have the results. And if everything's good, my database should look something like this. So I'm back in the SQL developer, and this is my output table, and this is my data. So now I have, based on the species and the year, it shows me how many count is there per cell. I would like to demonstrate this in our CADenza software and the web portal. So we've already configured our software or the map to directly access the data we just generated now. So these were the initial points of observations from the Excel file, and the grid, it looks in the background like this, and this is the result that we generated later. And this would help us to dynamically filter our data based on certain criteria. For example, here I can just filter the values only in the year or for a couple of years, and I can click on a certain cell, and here then I have the count for each year for that particular grid. Okay, so that's Talend for you with the GeoSpatial integration. To summarize, I'll like to go back to my slide. Yeah, this one, right. Okay, so this is the current scenario which we implemented for our customers in Saxon. And to summarize, yes, this is to look at the big picture. A data warehouse usually has the following layers. You have a source data, which has so many sources from different databases and Inspire and code lists. And you can use the GeoSpatial component now in Talend to process both your spatial and non-spatial data all-in-one in the same platform in different layers of data warehousing. You can control the quality of your attributive data or the spatial data itself. You can use it in the layer of data storage or in order to generate various output that makes information meaningful for your project. So I hope I have increased your curiosity with Talend and the GeoSpatial plugin. Thank you so much for listening, and please feel free to download our software from our website and try it out for yourself.
Okay, thank you very much.